Hello the internet and welcome back to my channel. Today on the bench we have a slot 1 motherboard. It's an Asus P2L97. This board is not in the greatest shape, there's some components missing, there is quite a lot of damage, and today we're gonna try and fix all the damage and see if this board actually works. Now this board comes from Dubai, from Alex, aka Bits and Balls. I'm sure you know his channel. If you don't, just go and take a look at it because it's absolutely amazing. And this comes from the fantastic Scrapyard. Now I'm very jealous of Alex's Scrapyard because we don't have them in the UK. Well, we do have recycle centers of course, but members of the public are not allowed to take items at home from the recycle centers. Now there are some missing components on this board. There is a ripped capacitor, there probably are some damaged traces at the back, so there is no point in trying and power it up. So let me thank today's sponsor, PCBWay, and I guess I can try and show you all the damage on this board, and then we'll move under the microscope and we'll take a look at those traces. First thing first, the broken or missing components. Now these crystal here, the legs are mangled, they might be broken, we'll take a look under the microscope in a minute, but on the other side of the board there was another crystal which is completely missing now, so we need to replace this one. I believe that this capacitor was ripped off the board. It looks like it's been resoldered, but no, I think that what you're seeing is what is supposed to be inside the capacitor, so I will need to replace this one. And having been in a scrapyard, this board has the usual assortment of mangled pin terminals. I'll have to demangle all of them all around the board. Now the whole I/O section is in pretty bad shape. It's still usable, it's not too rusted. Hopefully the USB and the PS2 are gonna work. Before we move to the back of the board, a quick look at the missing crystal. It really looks like it's been removed on purpose. Though if I'm looking at the legs are actually rusted, so maybe the crystal just rusted and fell off of the board. And this is the other crystal, is not in a better shape. I think the legs are either rusted or they're touching, or probably they're about to fall off. Still at the front of the board, I found some damage here by the power connector, and that's a fuse, I believe. And once again, there is some damage here, but I don't see any damage anywhere else. All those other SMD components are totally fine, so I'm not entirely sure what happened here. And it looks like we're in luck, because the fuse is still working. Whether I want to trust it, I'm not sure. I haven't got replacement, so I guess for now that's gonna be fine. You can't see this from here, but there's been an impact here on this leg here, but it doesn't seem to have detached. Everything seems to be solidly soldered, so maybe that doesn't need any attention. And last thing I can see at the top of the board is a little bit of scratches here and there, but I don't see any damage on those traces. And maybe there is a little bit of corrosion on some traces, but I don't know, I might take care of that, but there's really nothing that should stop this board from working. Now, let's move to the back of the board. That seems to be much more interesting. And the back of the board is not as bad as I thought. There are quite a few small scratches, but I haven't found anything that is deep enough to cause a damage to any trace. Like this one, for example, I don't see any damage on any of those traces. And even this area here seems to be totally fine. This is definitely more severe, but if we look closely, you will see that basically there is no damage to the big trace. However, I'm noticing something a bit weird. I'm not sure how to explain. Like this pin, for example. This is one of the capacitors. I'm not entirely sure I understand how that happened. I guess the pins at the back of the board has been like grating things at the boards probably at the scrapyard, and eventually the solder just detached. The leg seems to be kind of solid, so maybe it's still attached on the other side. Obviously, I'll have to reflow that one. But that's not the only one. This is the RAM, so it's quite important. And there's another pin with more or less the same problem. The pin is actually not there anymore. I'm not entirely sure how all the others seem to be fine, but that is missing. But anyways, that's definitely been snapped, and it's kind of detached from the rest of the solder joint, so I'll have to redo that as well. This is one of the PCI slots, more pins to resolder. Another PCI slot, this is a sea of detached pins, I don't know how to call them. And finally we got some on the ISA slot as well, just so that everybody is happy. I guess the AGP is the only one which is not affected, or maybe I'm just missing some. So there are quite a few things to do, but nothing too major. We are here at the back of the board. I would say let's start with those joints, and then maybe we can replace that capacitor, and then we'll flip the board, go at the front and replace those crystals. Alright, it's time to test this board. Now, before I plug anything into it, I'd like to just do a dry test. So, power it up without anything connected, in case anything happens. 3, 2, 1, go. Yep. The eye is flashing. Clock is flashing, that's not a good thing. But at least we have everything, I think. We have all the voltages. And let's double check the reset line, because I didn't pay too much attention. 3, 2, 1, go. Yes, reset line is working. Clock is flashing, which is not great, I guess. I have no idea whether that could be something, but there is a clock I see here, so if we have an issue with the clock, maybe something I can fix. Time to populate this board and see if it actually posts and boots. I got Pentium 2 at 233 MHz and set the jumpers accordingly. This motherboard is completely manual apparently, which I guess it's an upside if you want to do a little bit of overclocking. As you can see, the CPU doesn't have a heatsink. The reason is I haven't got heatsinks for slot 1 CPUs, so it will work for a few minutes, and then I don't know, I'll find a way to run some more tests, but for now, that should do. Really curious to see whether we're getting anything out of this board. Will it work? Let's power up the power supply, and let's power up the board. 3, 2, 1, go. No, it's completely dead. And the clock is misbehaving again. Now, let's make sure that the CPU is properly seated. Let's use some contact cleaner. Again, this board comes from a scrapyard, so let's use some contact cleaner there. No, still dead. That's a shame. First thing to do, as usual, is just to try some contact cleaner on the BIOS chip. I see some maybe oxidation, but the legs look pretty good, so I doubt that is our problem. Try again, 3, 2, 1, go. And still completely dead. Well, I guess it's time to investigate on why that clock LED is flashing. Maybe that's our problem. Alright, it's like a Christmas tree now. So I moved the postcard on the PCI slot and I don't see a clock light, but actually now there is. So it's just bad contact. Let's try some contact cleaner again. Oh, we got signs of life. 00C1. What happened? The clock is now working. I see the frame is doing something. And we do have some sign. I haven't got a speaker connected, I guess. No. So let's sort that out. What? Let's try this again. Oh, nice. Oh. It's doing something! Amazing! This is like RAM problem, fair enough. So we probably need to deoxid or, use some contact cleaner everywhere on this board. Or maybe it just doesn't like this stick, which is very possible. Try this again. Okay, well, oh no, it's doing something now. It's definitely posting. I've got codes here. Unfortunately, I need a PCI adapter here. But it only started after a few seconds. That's weird. Let me go back to the ISA slot and see if you're getting anything here. 3, 2, 1, go. Now it's working. Well, Okay, well, let's go back to the video card, and I don't know exactly what happened. Might be me flexing the board, maybe there's still something wrong with it. We'll test in a minute. Let's plug the video card back and see if we're getting anything out of this board. I think I should probably bathe this board in contact cleaner. 3, 2, 1, go. We do have activity. Do we? Yes. It's working. Look at that. Why wasn't it working before? But this is so cool. Let me try and flex this thing. Is it stopping working? I don't understand. Maybe it was some really badly oxidated contact on the CPU, on the RAM or something, and the contact cleaner worked over the past few minutes and fixed that, because that's the only thing I can think about. This is definitely working. And the clock is not flashing anymore. And the board is totally working. It's posted. I'm in DOS. And now I need to find some sort of a heatsink for this CPU, unfortunately. I can't really run any tests without a heatsink. So let me see if I can patch something together, because I really haven't got anything for this. Yes, I know that some of you, probably all of you, will cringe at this, but it seems to be working fine. Meanwhile, really, I need to find an alternative to that, because obviously, this cannot be a proper alternative, but this hopefully will work. It doesn't touch the RAM. I'm actually impressed. It's, well, almost. I need to put something in between. Or maybe I need to move the RAM to a different slot, if it works. Let's use some contact cleaner, because this thing is pretty crusty. I know, you're screaming at the screen right now. Ooh. No. Oh no! The clip broke. Okay, it was glued already. Someone glued it in place. How can you possibly glue a RAM clip here? Obviously, it's gonna fail. Right, this is the definition of how not to put together a computer. But, let's see if it works. Let's see if I can run some Doom, some benchmarks, make sure the things are working. And then we'll check whether the BIOS is fully up to date. Turn it on in 3, 2, 1, go. Okay, well, the fan spins. And, oh, it's back to what I was doing before. So the clock is flashing and there is no activity. Let me wiggle the processor. No, okay, so what is it that is stopping this thing? Doesn't seem to be the processor. Doesn't seem to be the video card. Doesn't seem to be this. RAM, nothing. Okay, it's dead again. Interesting. Now it's working. Maybe. Not entirely. But the clock is not flashing anymore. And now it's working. So, yeah. Yeah. Is that the CPU slot then? Or something with the PCB? And when I'm flexing the board... BIOS revision is 1005, by the way. Let's put the fan back in. This is so bad. Well, it seems to be working, so happy days. I think, just out of curiosity, I'd like to have a look at that CPU slot under the microscope and see whether there is some heavy traces of corrosion or oxidation. And there's really nothing I can see on the slot. Everything seems to be pretty nice and clean, to be honest. So I'm thinking, let's double check the back of the board. Remember, we had some of those pins which were detached from the solder joint. Maybe I missed something there, and there's a pin which is barely making contact. Let's take a quick look. And yes, I've noticed something. Nothing too terrible, like this one is not too bad. And this definitely didn't have a good time over its life, so definitely these two will need to be resoldered, reflowed. I think I'd like and reflow them all. Only gonna take a few minutes, so why not just get a small tip and just do each one of them one by one. Some time ago I realized that my postcard analyzer couldn't be seen by my overhead camera, so I went ahead and designed this little 90 degrees ISA adapter here, which obviously was manufactured by PCBWay, the sponsor of this video. It's a simple adapter, it's nothing really special, but it's nothing I could find online, so I made this little design, which is really nothing special, and the design is available on the PCBWay store. It's also available for free download, so it happens to live on the PCBWay store, but you can download and do whatever you want with it. I also made a 16-bit version if you need to diagnose something like a 16-bit card, like a sound card or a video card. But whenever you need a PCB, well, clearly PCBWay is your stop. The process is extremely simple. If you're purchasing from the store, it's super simple. You just put the item in your cart and you purchase. If you have a project that maybe you found online or you design yourself, it's just as simple as finding the Gerber file of your project, uploading on PCBWay.com, following the instruction. The system is more or less automatic. I tend to change the color of the PCBs for my project and then choose a postal service, and PCBWay will deliver the PCBs at your place. So whether you need a PCB, 3D printing, metal sheet fabrication or CNC machining, I'm very happy to recommend PCBWay. Take a look at PCBWay.com, the link is also down below in the description, and let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible, so thank you very much PCBWay. Now let's continue with this Asus motherboard. Let's see if this time it works straight away. Power to the power supply, and 3, 2, 1, go. No, the clock is flashing again. What is this? Is this something with these jumpers here? That's the clock selection. I bet that now, if I reset the board, it starts. Yep, it's something with the jumpers here. The jumpers are probably like corroded or oxidated, and yeah, and the clock is unstable until I move things around, I tap the board, something happens. What I can do, I can spray some contact cleaner on it and just move them in and out again, out and in again. And let's try again. Power to the power supply now, and 3, 2, 1, go. No, it's still flashing. Okay, that's interesting. But if I'm touching here, it stops. Let me try with different jumpers, like new ones. And let's try again. Power up now. Oh, and it works straight away. So, yeah, it's posting. So, are these jumpers like crusting inside? Hardware monitor found an error. Enter power manager setup for detail. Really? That's new. Keyboard doesn't work. That's the error. I guess the PS2 connector is also crusty. Well, the keyboard is working, but I still have the error message, so let's go on the power management. I think that's just the fan. I might have connected, yes, I might have connected the fan to a different one. I don't know. What's the difference? The error is caused by the fan monitor section, expecting to see a fan connected to the CPU and chassis header. However, the fan I'm using is apparently too slow for the BIOS, and while its speed is being detected, it triggers an error. And while testing the headers, I noticed that the power fan header, located close to the power ATX connector, is not reporting a speed at all. Of course, for now I can disable the speed monitor on all 3 headers, and that will take care of the error when posting. But let's take a look at the power fan header. All fan headers on this board are 3 pins, so they are not PWM. 1 pin is 12 volts, 1 is ground, and the last is the tachometer signal going back to the board. I found that all 3 signals converge onto this IC. It's a Wimbund W83781D. It's indeed a hardware monitor IC, able to monitor 3 temperature sensors, 5 positive voltages, 2 negative voltages, 3 fan speeds, and a case tampering switch. And the output is a serial signal going back to the system. Now, because 2 fan headers are reporting the speed correctly, that means that the IC is working, and I can only assume that the tachometer pin of the power fan header is not reaching the IC. Unfortunately, it does. This resistor network is a pull-up resistor. It's got 5 volts on the left-hand side, and I can trace all 3 tachometer signals here. The first leg on top is the chassis header, the next is the CPU header, and the third one is the power fan header. The power fan header then goes into the hardware monitor IC, and I can measure continuity up to the leg of the IC. The pull-up resistor also works, and that means that this input is not working, as all other fan speeds, and also the voltages and the temperatures, are being reported as expected. My only option is to reflow the IC and hope for a miracle. Which unfortunately did not happen. The power fan connector still reports no RPM. So I concluded that the IC was faulty. Until I plugged a faster fan on the connector and, surprise surprise, the BIOS screen showed the speed as expected. So this tachometer input doesn't like my slow fan? Is the fan somehow faulty but working on the other headers? Well, I don't know, but these turned out to be a known issue, so let's move on. While diagnosing this fan speed error, the clock IC LED started flashing again, so the fault wasn't fixed by the new jumpers. Let's take a look under the microscope. Here's the clock IC, it's a classic ICS 9148BF-04. Let me poke around and see if I see anything wrong, otherwise I guess I'll reflow everything, and hopefully that is it. Alright, so no, it's still doing it, and I have a feeling, unfortunately, we might have a faulty clock IC generator. Let me show you how I came to that conclusion. So now the board has been off for a few seconds. If I turn it on, it's working totally fine, and I set the board so it powers on automatically whenever I give power, so I don't have to fiddle with the tweezers. And I found, with my usual tool, cold spray, that if I cool down the IC, give it a sec. If I turn it on, look at the clock LED here. That's it, it's flashing and the board is refusing to start. Now, the clock eventually will stabilize. We'll try and visualize it with the oscilloscope in a sec. Once the clock stabilizes, which usually can also happen if I put my finger on the IC, and once it's stabilized, if I just reset the board, it actually starts. But what I found is, while the board is posting, if I cool down the IC, or the area actually, the clock will start misbehaving and the board should have crashed. Yes, it's not doing anything anymore. So there's definitely an issue there. I'm not entirely sure it's the clock IC, but it's kind of feel like it's stabilizing once it's cooled down, once it's warming up. Obviously, with hot air and cold spray, it's difficult to be precise. So let me try and visualize this with the oscilloscope. I guess it could be a bit more meaningful if we actually see what happens to the clock. Oscilloscope is up, and I have a long ground lead, so the signal is going to be a bit noisy, but if I power on, 3, 2, 1, go, you see that we have, it says 64 megahertz, it's the 66, there's no video card, so it's going to complain about it. And this is when it works. Again, ignore the noise, that's, I'm assuming it's my ground lead. And if I cool down the IC or the area, look at that. The signal basically disappears, and what I see, I'm not sure how much is visible via VNC, it's a bit lower. There it is, it's back. It looked like a data line. It didn't look like the clock IC anymore, unless it's what my ground leads picking up, which is very possible. But now it's not happening anymore. That's interesting. I tested before shooting this section, and it was happening every time. Now, it doesn't seem to happen anymore. Look. This is going to be more or less impossible to diagnose if it doesn't happen every single time. Right, so I was recording an outro basically saying, well, I can't replicate the problem anymore, so I'm not sure what to do. There's no point in doing much, but I hope you enjoyed the video, blah, blah, blah. And then I touched the motherboard in this area here. I had Doom running and Doom crashed. And I realized that every time I was touching that point, the motherboard was crashing. So I started recording another section saying, well, maybe there is another problem. And I flexed and touched the motherboard a few times, and now the motherboard is doing this. Turn it on. And basically never stops beeping, unless I push it here, and then the whole motherboard crashes. Look. Well, yeah, it crashed while it was beeping, so you have a solid beep. So I guess there is still some work to do on this motherboard. I can't give up right now. My only concern is that these things are clearly intermittent. They come on and off depending on how the motherboard is flexed, and this is clearly a bad joint, I guess, and it could be absolutely everywhere. So I'll take another look. Maybe I'll redo some solder joints, but it could be under the BGA as well. It could be anything, and I'm not entirely sure that this is the same problem that we are seeing with the clock. I have a feeling this is a separate problem. So yeah, I'm happy to persevere with something which I can't fix, but something which doesn't appear all the time becomes undiagnosticable, if I can even say that word. So let me spend a little bit of time. I'll flex the board and see what I can do, and then I'll come back to you with my findings. Alright, I've been poking around this board for quite some time, and I've tried to shoot this section a couple of times, and the behavior changes every time, so it gets confusing. Let me try this again. So, the board is completely unstable, and I'm powering up the board without the video card, and unless there's something wrong, I understand that the board will try to post, and then will keep beeping indefinitely. And I'm using that beeping to ascertain whether the board is still working, or whether it's crashed already. So let me show you. If I power up the board now, it will start posting. It will keep beeping, and as soon as I apply some mechanical flex to the board, Non lo fa più, Maremma zoppa. That's it. This time it took forever, but the board will basically stop in the last state, and what I need to do, I just reset the board, it will start again, and I can do my diagnosis again. Now, unfortunately, I haven't been able to find a specific spot with hot air, cold spray, the soldering iron, where the issue happens every time. And actually, as I said, this is the third time I'm shooting this section, because when I thought I found a spot, I turn the camera on, probably the board cools down, and then when I go and warm up that spot again, it doesn't happen again, because I guess the board will slightly warp with continuous heat, several attempts trying to locate that point, and eventually the board has enough warp to cause some issue somewhere else. PCBs will flex a lot. Take a look at my latest short when I'm showing where the boards are really flexing. So let me replug the beeper here. Let's reset the board. And let's get the hot air. This is running at 300 degrees, pretty low airflow. Board is beeping, and let me see if I can show you what I mean. That's it. I found that that corner of the BGA of the south bridge is usually stopping the board, but it's not only that one. I can try in this area here. It's taking a little bit more time, but also in this area here. So this is telling me that there's probably nothing wrong with this component, with that component. Not sure about the BGA. I think it's just the board is flexing slightly, and I'm assuming either one of these components is losing connection with the trace, with the pad, or more likely the BGA has a problem. And you know how unhappy I am to work with VGA, but this board is unusable, so all I can do right now is to check everything under the microscope and maybe reflow everything I can find, take a look at the back as well, and then I guess I'll have to reflow that BGA, that south bridge, because right now the board is completely unusable. And you can see how easy it is right now to crush the board by just warming up this area here. Let me go around with the soldering iron first, and then we'll try a reflow and we'll see what happens. And while reflowing all these components, I stumbled into this. What the is that? Wait a minute. What is this? A cracked capacitor. Now, I doubt that this could be our problem, but obviously it shouldn't be like that. And you never know, this capacitor might be shorting something intermittently, because obviously it's wedged between where it's supposed to be and another components nearby. Alright, will it work? I seriously doubt it, but you have to start from somewhere. So, let's power it up. 3, 2, 1, go. Oh, now we got the the clock issue, so I don't know, it needs to stop. Oh my gosh, this board is a nightmare. It keeps giving. And no, the board has got worse. I mean, now we have that clock issue. I'm assuming the clock has disappeared, as we saw before, and it doesn't come back. So is that issue that we had before linked to the clock, I don't know. It could be, maybe, maybe not. But now that the clock is misbehaving, we can check, without turning this off, we can check whether the reference clock is actually working, because that would be the first step in diagnosing why the clock is not working. Right, I'm about to check the reference clock of the clock IC. I haven't turned off the motherboard because I don't want this to suddenly start working and I'm losing my opportunity. I've got plenty of lead extensions here, so the signal is going to be pretty dirty, but we might be able to see something. So this is the clock output of the IC, and as we saw yesterday, this is exactly what's happening. Basically, there's no clock. Now let's check the reference clock, the 14 megahertz, if I'm not mistaken, coming in, and I'm not sure I'm seeing anything here. Again, I got plenty of lead extensions, so I'm not sure how much we can trust it, but I think I'm supposed to see something. This is supposed to be a 24 megahertz output. I really don't see much coming out of it. And this is supposed to be 48 megahertz, I think it's for USB, and also there's not much. But obviously, if there's no reference clock coming in, well, then we do have a problem. The chip is not going to work. And this is straight with my oscilloscope, so no, there's nothing wrong with my lead. The lead is obviously making the signal dirtier, but we don't have a reference clock going in, and that's our problem. I'm not sure that's anything to do with the flexing of the board, but that's definitely something to do with the clock issue. So I went ahead and borrowed the crystal from a donor board. After removing the allegedly faulty one, I'd made sure that we had continuity between the crystal pins and the clock IC pins. Let's see if it works with the new crystal. 3, 2, 1, go. And it's still flashing, as I was kind of expecting. So the next step would be to make sure that the IC is getting the voltages and it's got ground, and then we need another IC, another clock IC. This IC is supplied by several pins, so let's check them one by one. We got pin 48 VDD-L1, and we are measuring 2.5 volts, which I believe is correct. Then we have VDD-L2 pin 42, and we have another 2.5 volts, which I believe is correct. We have a VDD3 on pin 36, 1.7. And we only have 1.7 volts on VDD3, but according to the datasheet, that should be 3.3 volts. So let's continue with the other pins, and let's put a question mark on pin 36 VDD3. We should have the same VDD3 on pin 30. And yes, we have the same 1.7 volts, which is weird. And we should have the same VDD3 on pin 19. Yeah, same voltage. VDD2 on pin 14. We still have 1.7 volts, which is weird. And again pin 6. And once again we have 1.7 volts. And VDD1 is also 1.7. And that's it. So only VDD-L1 is actually different, 2.5 volts on pin 48. Yes, let's check whether that's supposed to be 2.5 volts. And yes, both VDD-L1 and VDD-L2 are supposed to be either 2.5 or 3.3. But I feel we have a problem with the other voltages because they're not supposed to be 1.7. Alright, I've been poking around the board again, and I'd like to show you what I found. Now, this board is using 3.3 volts somewhere else, and that would be the RAM sockets and the AGP sockets. Also, this is an ATX board, and 3.3 volts is coming from the power supply. So first thing I thought is, do I have an issue with the power supply? It's unlikely, because otherwise the RAM wouldn't work, the video card wouldn't work, but you know, it's the first point where to look at. I went to check the 3.3 volts line, turn on now, and I'm getting 3.3 volts. So that is totally fine, and obviously that is not a problem. So next step is the RAM and the AGP getting 3.3 volts? The RAM is getting 3.5 volts, and the AGP is getting the same 3.5 volts. Now, because it's slightly higher than what the power supply is delivering, I guess there is a 3.3 volts generation on the board. And I guess this is maybe because older ATX power supplies, not all of them have 3.3 volts. I'm not sure. Let me know down below if you know about it, because I would expect that on an ATX AT board, and AT power supplies definitely don't have 3.3 volts. I don't know, maybe because older ATX power supplies maybe didn't have enough power on 3.3 volts to drive AGP cards, I don't know. But I can see that we have basically 3 areas of voltage generation on this board. You can see that you have basically 3 inductors. Where you have an inductor, especially when you have 2 semiconductors like this, that's where that's the back converter. It's converting, say, 12 volts to something else. So checking in the inductor, I'm getting 3.518 volts, which is exactly what I'm getting on RAM and AGP here. And on this one, Well, I'm getting 0.43, but I have a feeling that this is the voltage for the CPU, and because the CPU is not there, you don't have a voltage. Let's do a quick check. And yes, with the CPU installed, the voltage goes up to 2.8, so it's totally fine. So this seems to be the generation of 3.5 volts, which goes to the RAM, which goes to the AGP, and I can confirm that by checking continuity between the AGP and RAM power lines, and also checking continuity between this inductor here. And it's the same circuit, so this circuit here is powering the RAM and is powering the AGP. Now, I'd expect this circuit to also power the clock generation IC, but if I'm checking continuity between the inductor there and pin number 1 of the clock IC, I'm getting kilo ohms, so that's not right. So I was looking for another place where voltage could be converted, conditioned, generated, something. I couldn't really find anything. So I started poking around the clock IC, and it took me quite some time because I couldn't find where that voltage was going. I was looking for any component that would be linked to pin 1 of the IC. I found this component here. Is that a diode? And on the right hand side is directly connected to the voltage, to the supply rail for the chip, and on the left hand side is connected to ground. And then eventually, by poking around, I found this little inductor here. It says L10, and on the right hand side it is again directly connected to the supply pin of the IC. Now, when you check an inductor with the multimeter in continuity mode, it looks like a short, because an inductor is a short. It's just a way to filter out high frequency spikes. It's like swimming in oil. The inductor will let slow changes through, but not fast changes through. There's another inductor here, L5. If I'm checking it with the multimeter, I'm getting that short. But if I'm checking this one, I don't get anything. And this is impossible. It's an inductor. It should read that short. And if I check for continuity between the other side of the inductor and my 3.3 volts line here, there we go. That's my 3.3 volts line, which is supposed to go through an inductor. The inductor is broken, and the inductor is not letting the voltage to the IC. Let's take a look immediately under the microscope. This doesn't look too bad. There's no obvious crack. I see a little line on the left-hand side. I'm not entirely sure. But I think what happened is that this component was working intermittently, was making contact intermittently before I reflowed it. And that's why when I was touching the board, warping the board, the clock would stop probably for a split second, just enough to crash the whole system. Then I went and reflowed that component as well, and probably that broke it for good. Obviously this is not working because I'm reading 33 kilo ohms, so let's remove it, and I suspect that the moment we remove it, it will probably fall apart. That's it. It's cracked. Oh my god. Yeah. And as predicted, the inductor cracked while I was removing it. So the next step would be to remove the remain of the inductor and then replace it. Now, I don't know what kind of inductor that is. So I went ahead and just got a random inductor from another board of a complete different type. I know it's not ideal, but it should do. And I now have continuity between the 3.3 generation and the 3.3 supply voltage of the clock IC. Will it work? Let's test it. Let's take a look at the clock LED. 3, 2, 1, go. Yes, it's solid. It's solid. Let's plug the CPU, video card, everything. This board might actually work now. 3, 2, 1, go. Yes, it's posting. Okay. Right. Okay, so the beeping is still happening, but I can flex the board and it doesn't seem to stop. So the beeping was a different fault? Isn't that just the video card? So I switched the video card, as I believe the long beep followed by 3 is video card problem, and it does output a video, an image, but it's corrupted. I'm not sure what's going on. I have no idea. And even with another AGP video card, I have the same error. If I remember right, it started doing that before losing the clock. So, and even with an ISA video card, I'm getting the same video corruption issue. Now, just as a very quick test, I got my Intel out and I got the CPU, the same RAM, the same video card, just to make sure that nothing happened to the CPU or the RAM or anything. And if I turn this on, it does post. I do get a picture out of it. So there's nothing wrong with the CPU, there's nothing wrong with the video card, the RAM or anything. There's definitely something wrong, again, with that board. At some point I asked for some help on Vogons, and a user there, PC Live, quite confidently said that with those postcodes, it's a matter of BIOS. Just reflashing the BIOS would fix this problem. Now, I really don't think so, because those BIOS codes, they seem like normal BIOS codes, and just the progress of codes just gets interrupted for whatever reason, but it doesn't hurt it. I don't even need to use UV lights to erase this one, so why not? Let's reflash the BIOS. Now, first thing first, out of curiosity, let me load the BIOS that I downloaded from the retro web, and let's do a verification with the BIOS which is present on the chip itself. Okay, well, we see some differences. Let's scroll down and see what we're talking about. Right, so this is like a whole block of data which is supposed to be FF and it's something else. And I feel that these are just the user configuration parameters. When you go into the BIOS and you change parameters, this is probably the area where they get saved. Because everything else looks absolutely identical, so I don't think this is gonna fix anything, but hey, it doesn't cost me anything. Let's flash a fresh copy of the BIOS onto the IC and then we'll put it back on the board and we'll see what happens. Is it gonna work? I don't think so. 3, 2, 1, go. That's different. What is... It's... It's working! What? The BIOS? Oh my god. How is that even possible? The BIOS was doing that. Wow. And the board is now stable, I guess? Let me run something and let's make sure the board is actually stable. And the board is working and it's totally stable. I can flex it and poke it and push it and touch it and flex it and it works. I can't believe I didn't know what to do. It was just such a weird thing, and I thought there was some issue with the BGA, the South Bridge, the North Bridge. No, it was just the BIOS, which is weird because we flashed the BIOS earlier on, so it's not really bit rot. But I guess that restarting the board like 1,000 times with an unstable clock, probably the BIOS didn't like it. So a massive thank to PC Live on Vogons for giving me this idea, because I'm not sure I would have thought about that. PC Live, your profile says Italy, so grazie veramente tanto, perché questa scheda la stavo per lanciare dalla finestra, guarda, grazie, grazie, grazie. And I'm really so happy to have this board completely fully working at the end of this video. And I had already shot an outro of this video announcing a part 2, because I thought, well, that probably is going to require some diagnostic and this video is getting already too long. Well, I had great fun fixing this board. It started as a simple repair, like swapping a couple of missing crystals, and then it turned into something a bit more challenging. Still simple, but still challenging. I'm so happy the BGA is not involved on this board. If you enjoyed this video as I did shooting it, well, then I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon, and the links are also down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, which is very much understandable, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, totally understandable, and I do appreciate your time here, and I hope you enjoyed this video. That's it for today. I wish you a great day, and I hope to see you again here soon on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.